Okay, so we're going to be looking at names of polygons, all right? So names of polygons. It will really, really help you if you guys write these notes down. Now, polygon, what does this thing mean? Now, let me break it down. Poly means many. Right? In Algebra 1, you guys learned polynomials, many terms, right? There was like a trinomial, quadnomial, binomial, right? You guys learned those. You guys should remember those from Algebra 1. Your Algebra 1 teacher should have covered that. So poly means many. Gon means sides. So polygons means figures with many sides. To begin with, a side is something straight. A circle has no sides because the outside of the picture is not straight. Another rule that polygons need to have, so like I said, it has to be straight, not curves. So curves are not good. It has to be straight. So the sides have to be straight and connected. Okay, so what do I mean with this? That there's no spaces in between. So let's say I have one figure there. I have two sides there, but they're not quite connected. So the minimum amount of sides a polygon can have is 3 sides. For today, we're going to be looking at pictures based on the amount of sides. So the number of sides, I'm looking at 3 sides, something like this. Now, this is a figure you guys learned back in like, I don't know, kindergarten or before kindergarten. A figure with 3 sides, we call this triangle. Very interesting figure though. Very, very interesting. We're gonna deal with many triangles. There's types of triangles. We're gonna deal with those later. Now, 4 sides, you learn a few shapes, right? There was some specific like a rectangle. Remember the rectangle? Remember a rhombus? Right? You guys, some people call those diamond. You remember a squared? Okay, so there's many figures that have 4 sides. Now, the one name we're going to use for all of them, like I said, they're specific, like rectangles, rhombus, squares, kites. There's many of them. The one name we're going to use is quadrilateral. Because quad means four. So quadri means four, and lateral means sides. So 4 sides, we're going to call those quadrilateral. Now, a polygon with 5 sides, so let me think how this thing looks like. Would look something like this. Polygon with 5 sides. There's even a building in Washington, D.C. They control the army there. It's a building with 5 sides. It's a very, very important number. It's a very, very important building as well. Now, 5, we're going to call this a 5-sided figure. We're going to call this, to begin with, let me just write penta, because penta means 5, and then gon, which means side. Pentagon means 5 sides. You guys have heard the phrase penta. At this moment, Brazil only has, in soccer, guys soccer, Brazil is the only team that has 5 championships, 5 World Cups. So this time we call them penta champion. Penta means 5. So pentagon means 5 sides. Penta, 5, gon, sides. Now 6, a figure with 6 sides. We can draw it. That's 1, 2, 3, 4, 5, 6 sides. We're going to call this hexagon. Notice I finished with the phrase gone because it's sides. 7 sides. I'm not going to quite draw them anymore, but 7 sides. We're going to call this heptagon. Be very, very careful. Make sure you guys write this on your notes. Heptagon. Let's take a look at here, the number of sides. 8 sides. Some of you guys watch the UFC, right? It's a ring that has 8 sides. Now, 8, we usually call that octa. Because it's 8 sides, we're going to call this octagon. Interesting. Now, 9 sides, 9, we're going to call that nonagon. Nona sounds like 9. So nonagon means 9 sides. Now 10. Think of a period of 10 years. How's that called? Period with 10 years. Decade, right? Decade. So a polygon with 10 sides, we're going to call this decagon. Now with 11 side, we're going to call those on decagon. And 12 sides, we're going to call those dodecagon. Notice how they finish with decagon. What? 1 and 10 make 11. 2 and 10 make 12. Now, polygons can have more than 12 sides, but I'm going to stop at 12. Polygons can have more than 12 sides. Imagine I have a polygon with 45 sides. I'm not going to draw it, but we can. We can have a polygon with 45 sides. Now, I'm not going to have a name for that. I'm just going to call, if that was to happen, I'm just going to use the number. So in this case, 45 dash gone. So if I have a polygon with more than 12 sides, I'm just going to use the numbers. In that case, it will be 45 and then put a dash, gone. So imagine, what if I had a figure that had 100 sides? Well, 100 gone. All right, interesting. So I'm just going to go up into 12 sides, but polygons can have as many sides as we want. To begin with on your homework, I'm going to give you guys a polygon. Right, notice how the sides are all straight. They're all connected. So it is a polygon. I'm just asking for the name. So what I'm going to do, I'm just going to count. So let me put N for the number of sides. I'm just going to count how many sides my polygon has. So let's see, 1, 2, 3, 4, 5, 6, 7, and 8. It has 8 sides. Again, my N represents how many sides there are. I just gave you guys a list, right? I can go back to my list. So make sure you guys have it on your notes. A polygon with 8 sides, I call that octagon. Let's take a look at number 25. Let me count the sides. So I'm going to put N, the number of sides. So let me count it. Let's see, 1, 2, 3, 4, 5. This figure has 5 sides. So I want to call this pentagon. Later on, we're going to deal with even regular polygons. So polygon means the sides, right? We're talking about figures that have sides and they're all connected. But notice on number 25, it is okay. Look at the picture number 25. It is okay for one side to be bigger than the other one, right? It is okay for polygons. Now, regular polygons, all the sides are going to be the same length. We're going to deal with those later. Not only the sides are going to be the same length, but the angles on the inside, they're going to be the same angle as well. Again, that's something that we're going to be dealing with in the future. Now, for today, I'm going to stop at number 29. So we still have 4 more to go. Now, let's take a look at number 26. I'm going to be using names like concave and convex. Okay, so I want us to be able to see a polygon, and we're going to be able to tell whether they're concave or convex. Now, what does concave and convex mean? Concave, think of the word cavity. Yeah, what's a cavity? You go to the dentist and the dentist says, "Oh, we found a cavity on your tooth." What's cavity? Cavity. What's a cavity on the tooth? It's a hole, right? They usually say, "Oh, there's something wrong on the tooth. We need to repair that." It's a hole. Really, it's really something wrong with your hole or with your tooth. So it's a cave. So cavity, it's a hole. What's a cave in a mountain? What's a cave? It's a hole in a mountain. So concave, let me emphasize the phrase cave. So concave, it's a polygon that has a hole in it. So question number 27, you guys see there's a hole in it, a dent in it. So matter of fact, if you guys have accidents, hopefully you guys never do, but if you guys have a car accident, the insurance gonna send someone to inspect the cavities, like that's what they call them, the concavity. They call it concavity, the dents. Okay, so this we're gonna call concave. And if it doesn't have any dents, it doesn't have any holes in it, we're gonna call it convex. So number 26 will be a convex. So if it has a hole, it's concave. If it doesn't have a hole, convex. Now, some of you might be, Leonzo, I'm gonna struggle looking at holes. How can I find out? Is there another way I can find out? And I'm gonna say, sure, connect two sides, right? There's corners on your polygon. Connect two corners. If you're able to, right? So we're gonna call those diagonals. When you connect corners, that is not a side, we're gonna call it a diagonal. If one of your diagonals happens to go outside of the picture, then it's a concave. Only one of the on diagonal needs to go out. So if I look at number 27, like say, let me connect two corners. To begin with, some of you might be like, well, that's a diagonal because I connected two corners and my diagonal is inside the picture. That's not concave. Okay, so we found a diagonal that doesn't go out. My question, what I said earlier was find a diagonal. I didn't say all diagonals. I said find a diagonal that goes outside of the picture. I was looking at this diagonal. So connect two corners, but that diagonal goes outside of the picture. That's concave. If it's convex, so I'm looking at number 27, you will not find such thing. Number 26, the diagonals this figure has are these. They don't go outside of the picture. So again, if a diagonal, not all, just as long as one diagonal goes outside of the picture, concave. If no diagonals go outside of the picture, convex. Now, looking at our triangles, let me label my triangles. Here it says, classify each triangle by its angles and sides. So there's two words that I'm going to use. I'm going to classify by angles and sides. Okay, let me talk about sides first. The angles is going to be easy. Let me talk about the sides first. We're going to have words like scalene. We're going to have words like isosceles. And we're going to have a word like equilateral. Oh, that sounds like quadrilateral, right? We saw polygons quadrilateral means four sides. So equilateral. What does that equilateral think it means? Quadrilateral meant four sides. What about equilateral? Sounds like equal sides. Okay, so equilateral. I'm gonna start the names from the bottom up. Equilateral, all the sides are the same side, same number. So equal sides, right? I can have a triangle with equal sides. That's equilateral. So three sides are equal. Isosceles, isosceles means only two sides are equal. And scalene, all sides are different. Okay, so again, the side scalene, all the sides are different. Isosceles, two sides are equal. Equilateral, all three sides are equal. So that's about sides, right? I was talking about the sides. When it comes to angles, we talk about angles on the previous unit. On actually last week, we talk about units. Remember, we talk about like acute, obtuse, right? Remember those? We talk about angles. Now, as a reminder, acute were angles that are less than 90. Obtuse were angles that were more than 90. And right were angles that are equal to 90. Now, when it comes to triangles, I'm going to give the name of the biggest angle. So I had to classify the triangles by angles and sides. So when it comes to angles, I'm going to look at the biggest angle. In this case, question number 28, my biggest angle is 104. Because look at my angles. I have 38, 38, 104. The biggest angle is 104. My angles are going to be those numbers inside of the triangle. So I'm just looking at the big angle. Then I gotta ask, is that acute, right, or obtuse? It is a number more than 90, so I'm gonna call this obtuse. When it comes to angles, I use the name of the biggest angle. As a matter of fact, every triangle has at least 2 acute angles. There's always an acute angle, at least one angle. Well, actually, at least 2 angles that are acute. So there's 2 angles that are always less than 90. It could be all 3. For all I care, it could be all 3. But I'm going to go with the biggest angle. Now, when it comes to sides, I see my numbers. 3, 3, 4.8. 2 of my numbers are equal. Therefore, I'm going to call this isosceles. So obtuse, isosceles. Cool. Let's take a look at number 29. Looking at the angles 40, 62, and 78, the biggest one is 78. Remember, I'm always going to give the name of the biggest angle. Now, 78 is less than 90. So that's going to be acute. Remember, less than 90. When it comes to sides, 13.2, 14.6, 9.6, they are all different. So therefore, I'm going to call this scaling.